Swayam Prabha. Digital India. Educated India.
Hello viewers, today we are going to start a new topic in this lecture series, that is on well foundation. So in this one, first we will see that what exactly are the well foundation, what are the various types of well foundation, and what are the various Indian Standard Code provisions which are available for design and analysis of this well foundation. So let us start with that what exactly is well foundation. We all know that when the loads from the superstructure are quite high and the soil bearing stratum is not sufficient, it doesn't have the sufficient bearing, then we need to go for deep foundation. So well foundation is one of that type of deep foundation. It provides a solid and massive foundation for very heavy loads. Then it is useful in the situation where the loads have to be transferred to the soil stratum which are deep below from the ground surface, like in for example in case of bridge foundation. Then this can be conveniently installed in a bouldery stratum which is usually found in case of bridge foundation. This is very widely used in India as foundation of bridge piers as well as the abutments. It is also useful as foundation where uplift loads are quite high, as you all know that in case of the transmission light towers, it is the uplift load which comes to the foundation and they are of very heavy in magnitude. So in that case, well foundation is quite useful. Now being a massive substructure, it is monolithic and relatively rigid in its structural behavior. Now coming to the types and well types of well, or it is called as caisson also. There are three types of well. One is open well, second is box well, and third one is called as pneumatic wells or pneumatic caisson. Now we will discuss one by one that what exactly are these three types, what is the difference between these three types, and when we go for the construction of these different type of well, what should be the caution that we should keep in mind while going for the construction, what is the advantage and disadvantage of these type of wells. So first let us start with the open wells. In case of this open caisson or open wells, top and bottom of the caisson is open during the construction. It can have any shape in plan, that is it can have it can be circular, it can be rectangular, or it can have oblong shape. Then it has a cutting edge which is fabricated at the site, and then the first segment of the shaft of the well is attached to it. Soil inside that shaft is being dredged out by some suitable means, and once that soil within that shaft is being dredged out, after that another segment of the shaft is being added to this previous one. Here is a figure where you can see the typical line diagram with respect to the open caisson. Here is the top and the bottom, which both are open, and the dredge holes, here you can see these are the dredge holes which are being created, and the soil in these dredge holes, they are being excavated by some means, that is, and after this well is reached to the required depth, these dredge holes, they are sealed with concrete when it is being sunk to the required depth. Now coming to the some of the features of this open caisson or well is that the process of sinking is continued till it reaches the required depth, that is what you have obtained from the design consideration and the bearing capacity of the soil stratum. Then once it is reached up to that particular level, the bottom of the well is being sealed with the concrete, and the shaft from where the soil has been taken out, it is refilled or the filled with sand. This type of well can be constructed up to any depth and cost of construction is relatively low. Some of the disadvantages associated with open wells, these are that the progress of construction in boulder soil deposits is very slow. Usually wherever this well foundations they are being provided, we encounter the bouldery strata. In case of the open wells, the construction in such a stratum is quite low, so this is one of the main disadvantage of open wells. The concrete sealed is usually carried out under water and therefore it is not very effective. Another thing is the bottom of the well cannot be inspected. So these three are the main disadvantages of open caisson or well. Now coming to the next type of caisson is box caisson. Now the main feature or how it is different from the open well is that in case of the open well, the top as well as the bottom of the well both were open, but in case of box caisson, it is open at the top but closed at the bottom. Here you can see the typical figure line diagram explaining the box caisson features. The top is open but the bottom is closed here. These some of the features of this type of caisson is that it is first casted on land and then towed to the site where it is sunk onto the previous level foundation base. So the prerequisite for the construction of this type of well is that you have to have pre-leveled foundation base before you start sinking the well, and this is to be first casted on the land and then it is transported to the site where it is to be sunk, and therefore this is also called as a floating caisson, where the loads are not that heavy and the bearing stratum is available at the shallow depth. There these type of wells are quite useful. Some of the disadvantages associated with such type of well, that is box caisson, is that first thing is that because it is the prerequisite that the foundation level or foundation bed has to be prepared in advance, so that becomes as one of the main disadvantage of such type of well. Then another thing is that bearing capacity of this base has to be properly assessed. It should not happen that the bearing capacity which has been assessed and the actual bearing capacity, they are not the same. The proper care should be taken to protect this foundation from the scouring action in case if the water is present. Coming to the third type of the caisson, it is the pneumatic caisson, and it has a working chamber at the bottom of the caisson which is kept dry by forcing out water under pressure and thus permitting the excavation under dry condition. So in both the previous type of well, that is in case of the open well as well as the box well, the construction was being done in the presence of water, but in case of this pneumatic caisson, usually it is basically it is done in under the dry condition and you force out the water under pressure so that you get the dry condition in the dredge hole and the construction of this type of caisson takes place. Airlocks, they are provided at the top and the caisson, it gradually sinks as the excavation is made. The typical line diagram showing this pneumatic caisson is here. You can see here that at the top two airlocks are being provided. air shafts are being connected to this airlock, and this goes inside the it creates the pressure with the help of the air, and that takes out the water, and such that here this dry condition is being carried out. On reaching the final depth, the working chamber of this pneumatic caisson is filled with the concrete. Now this has the advantage of better control of sinking as well as the supervision, because manually one can go inside and do the supervision. The bottom of the chamber can be sealed effectively with concrete as it is placed under dry condition. See, in case of open well and box well, in both the cases the sealing of the bottom or sealing at the bottom of the well is done under wet condition. However, in case of this pneumatic well or pneumatic caisson, the sealing is done under dry condition, and therefore it is much more effective as compared to the open well or box caisson. Obstruction during sinking, for example like boulders, they can be removed quite easily because the excavation takes place under the very high pressure. Some of the disadvantages which are involved with pneumatic caisson is that its cost is very high as compared to open well and box well. The limit, the second one is that the limit on the depth of penetration below water level is quite high. Like if you take for example about 35 meter of the depth of the well is equivalent to the pressure of about 3.5 kg per centimeter square, and these high pressure, they are beyond the endurance of a human body. Therefore, such high pressures are there, the site conditions become very difficult for the manual supervision and the construction of the well. Now these are, here we have discussed the three different types of the well, that is open well, box well and the pneumatic caisson. Now for any typical well, let us have a look on the component of well foundation. There are different components associated with any type of well foundation. We will discuss them one by one before we go for the analysis of well foundation. So here is the different components of the well foundation. Just you can have a look on this, that this top part, that is the girder, bearing, pier cap, and here is, this is the pier. These form the superstructure, and the load from this, that is from the girder, it comes to bearing, then the bearing transfers the load to pier cap, and then it comes to pier. And just in contact with the pier, the first component of the well foundation comes, that is the well cap. You can see here that this is what is the well cap. Below that, this well cap is connected to these vertical, you can see it's sort of a shaft, that is called as well steening. This is connected to a curb, that is a curved type of a structure, that is called as well curb, and a cutting edge is connected at the bottom of the well curb. It facilitates the sinking of the well. Now some of the other components, they are like, here you can see it's a bottom plug, here it is the sand plug, and the top portion which is in contact with the well cap is the top plug. Now let us discuss one by one the various components of these well foundation. The first one, as I just now discussed, is well cap. This is a RCC slab which is laid on top of the well steening and is usually cast monolithically with the steening. It transmits the load of superstructure to the steening. Now again, let us have a look on this particular figure and try to understand that how it works, or how the function of this well cap is there. The load which is coming from here, it comes to well cap. This well cap is in contact with this well steening, and it transfers the load which is coming from the superstructure to the well steening. The second component, the most important one in case of the well foundation, is the well steening. It comprises of the main body of the well, which transfers the load to the subsoil. This acts as a cofferdam during sinking and provide the necessary weight for sinking. So you see, the sinking takes place under the weight of this steining. So the thickness of this steining becomes an important aspect when you design the well foundation. Coming to the figure again, you can see here that this is having some particular thickness. The load which comes from the well cap, it goes to well steining and then it gets transferred to the subsoil. The next component is the curb, which is the lower wedge shaped portion of the well steining, and that is called as well curb. This facilitates the process of sinking. In the figure you can see that the bottommost portion of this well steining, which is running from this point to this point, and there you have this triangular kind of structure, that is the well curb, and this facilitates the process of sinking. Next component is cutting edge. It is the lowermost portion of the well curb, and that is the cutting edge. It cuts the soil during the sinking. You can see here that here this is the cutting edge. So when the well sinks under its own weight, this cutting edge helps the well to get sunk. The next component is called as bottom plug. What is done is that you know beforehand that at what depth the well is to be sunk. So once the well is reached to that required depth, then the base of the well is being plugged with the concrete, and that plug is called as the bottom plug. Now the function of this bottom plug is that it transmits the load to the subsoil. You can see here that here once this well has reached to a particular depth, here this bottom portion of the well is being plugged with the concrete, and this forms the bottom plug. So this is directly in contact with the subsoil, so directly it transfers the load which is coming from the superstructure to the subsoil. The next component is dredge hole. Now first we must understand that what exactly is this dredge hole. The well is sunk by excavating the soil from within the well. The hole formed due to the excavation of this soil is called as dredge hole. So this makes a major component of the well. Now once the well is reached at the desired or required depth, this dredge hole, which has been created because of the excavation of the soil within the well, it is filled with sand. Now this sand filling helps in distributing the load of superstructure to the bottom plug. How? We will just see in this particular figure. See, when you have excavated the soil from this, so here this will form the dredge hole, and once the well is reached to the required depth, this hole is being filled with the sand, and here you can see that this particular part from this level and on to the top of this bottom plug is the sand filling which is done, and this helps in transferring the load from the superstructure, and some of the load is being transferred to this sand filling and then to bottom plug. Coming to the next component, that is the top plug of the well foundation. It is a concrete plug which is covering the sand filling, usually which is constructed at the top of the well. It provides contact between well cap and sand filling and facilitate the transfer of the load from the superstructure, that is some part of the load from the superstructure to the sand filling and then to the bottom plug. You can see here that up to this point is the sand filling, and then the top portion is again being plugged with the concrete, and this forms the top plug. So now you can see that all the components, they are in contact with each other, like the well cap is in contact with the top plug, then the sand filling, then the bottom plug. So major load of the superstructure which comes to the well foundation is being transferred to the well steening. Some of the load comes to this top plug, then to the sand filling, and then it goes to the bottom plug, and then subsequently the whole load goes to the subsoil. Now we saw that the various components and their function of the well foundation, how the load gets transferred from the superstructure to ultimately to the subsoil. Now let us have a look on different type of shapes of the wells. There are many different shapes of the well which are available, which are here you can see in this particular figure is the circular well. Then the second one is double D well. You can have dumbbell shape. Then fourth one is broad necked twin wells with circular dredge holes, double octagonal with circular dredge holes. Then the last one is multiple dredge hole well. Now let us see that what are the advantage and disadvantages of these different shape of well, in what condition these are preferred, in what condition these are not employed. So the choice of the particular shape of well is dependent mainly on the base dimension of pier or abutment. Another factor which really affect the choice of the shape of the well is the ease and the cost of construction, the tilt and shift during sinking, and the magnitude of forces that are to be resisted for this for any particular well foundation. So taking all these factors like base dimension of pier, ease and cost of construction, tilt and shift during sinking, and the magnitude of forces, we need to take all these things into the consideration and then choose appropriate shape of the well. Some of the guidelines which are there as per IS code and in general also, that the most commonly adopted section of the well is the circular one. Why? Because this has the least perimeter for a given area of the base, and hence it is the ideal section in terms of effort which is required during sinking of the well. Further, as a distance of cutting edge from the dredge hole is equal, being circular in section, the sinking of the well is more uniform. So these are some of the two of the main advantage of the circular well. It is quite disadvantageous to accommodate a large oblong pier which would require a very large diameter well. In case of large oblong piers, 2 or 3 independent circular wells, they are placed very close to each other with a common well cap. See, usually this because this oblong pier, they take very larger diameter of the well, so it is better to replace such large diameter oblong well or pier with the 2 or 3 circular well, and those 2 or 3 circular well, they are placed very close to each other, and a common well cap is provided to all of these. A combination of independent wells is easy to handle, but the disadvantage with such type of independent well is that they have the tendency to get tilted towards each other during the sinking process. Tied wells of different shapes are preferred in order to avoid relative tilts between wells. See, if you are going to provide the independent wells, they will have the tendency to tilt towards each other during sinking. So to remove that particular disadvantage, usually these tied wells of various shapes, they are being used, and in these tied wells the tilts they are of within the permissible limit. Now usually the neck portion of the well is kept minimum, keeping in view the dimensions of pier and the dredge hole. Then coming to the other shapes of well, double D and dumbbell shapes are commonly used shapes of well after the circular wells. In case of double D wells, as the curved portion is much smaller as compared to the straight portion of the well, the lateral stability is considerably quite increased, and that is the lateral stability of the well is increased in the presence of double D wells. However, this straight portion, it makes the sinking process a bit difficult, as we all know from the common sense is that if a circular part is there, then the sinking will be more easy as compared to the straight portion of the well. So this straight portion, it increases the resistance to sinking, and it corners their corners, they pose a problem in dredging. These double D shaped wells, they have advantage in terms of being a monolithic structure. Double bell shaped wells, they have dredge holes as circular. Thus these have the advantage of twin circular wells in terms of ease of dredging. So you can go for the double bell shaped wells because they are just equivalent to sort of two circular wells. These double octagonal wells are not much in use because of the difficulty in the construction, because the straight edges of the well foundation, it really causes difficulty during the sinking, because they offer greater resistance during sinking on account of increased surface area. See, if the surface of the well is curved, it offers lesser surface area and the lesser resistance. Coming to the next case, that is for piers and abutments of very large size well with these multiple dredge holes are being used. So this is what is the shape of the well as far as the general guidelines are there, but some of the IS codes, that is 3955/1967, it deals with the shape of well. It has laid down some of the requirement for the horizontal cross section of the well. Let us see what are those requirements. The first one is that the dredge hole should be large enough to permit the drainage. That is, first thing is that dredge hole, that you have to decide upon the based upon the size of the pier, plus at the same time it should be large enough to permit the drainage. Now the thickness of the steining is also one of the governing factor as far as the shape of the well is concerned, is that the steining thickness should be sufficient to transmit the load and also provide necessary weight for sinking and adequate strength against forces which are acting on the steining both during the sinking of the well and the service. As I was mentioning when we were discussing the component of the well and we were discussing well steining, there I mentioned to you that the thickness of the well steining is an important aspect as far as the design and the analysis of the well is concerned. The thickness should be adequate, that it provides the sufficient weight which is useful in while during the sinking, plus at the same time the thickness should be adequate, that whatever loads are, because major part of the load is being transferred to this steining, so that thickness of the steining should be able to resist that much of the load which is coming to the well foundation. So while deciding the thickness of the steining, one needs to be very, very careful from these two points. Then the next requirement which has been laid down by IS code is that the well should be able to accommodate the base of the structure and not cause obstruction to the flow of water. Okay. The fourth one is that the overall size should be sufficient to transmit the load to the soil. That means the overall size of the well, it should be adequate, that it is able to transfer the whole of the load onto the soil. Now another thing is that IS code has specified some of the tilts and the amount of the permissible tilt and shifts which can be permissible there in case of the well. So the shape of the well should be in such a manner that it should allow for the permissible tilts and shifts of the the IS code further recommends that any shape that fulfills the above requirement which I have just mentioned to you can be adopted. Now, in case if the loads are quite high and it is required that more than one well is to be provided, that is the group of wells are to be sunk or to be provided, the minimum spacing between them, it depends on the depth of the well. However, as far as the general guideline they are concerned in design, usually this spacing is taken to be 1 meter. Now, this was all about the shape of the well. Coming to the depth of the well foundation, because this is one of the main parameter as far as the design or the analysis of the well foundation is concerned, that at what depth or what is the required depth for sinking the well as far as the loads are concerned. There are two important requirement that influences the depth of the well foundation. The first one is minimum grip length below the scour depth, and the second one is the base pressure which is to be within the permissible limit. So, while deciding the depth of the well foundation, these two criteria has to be kept in mind, and both of these has to be satisfied. That is, the minimum grip length below the scour level has to be provided, and whatever is the base pressure which is coming which is there because of the soil, that should be within the permissible limit. Now, first let us see that how we can find out the grip length of the well. So, first of all, before that, first we need to have a look on the scour depth, that what exactly do we mean by scour depth, and then we will see that what should be the grip length. The scour depth in a stream, this should be ascertained either by actual sounding at or near the proposed site during or immediately after the flood, before the scour holes have had time to silt up, or by theoretical methods, that is the Lacey's formula. So, either you conduct the test at the site to know this scour depth, or there are theoretical formula which are available for finding out the scour depth. One of this formula is Lacey's formula. So, here we are going to discuss the Lacey's formula, and we are going to discuss that how the scour depth is being evaluated using this. Now, as per this Lacey's formula, for natural streams in alluvial beds, the normal depth of scour, which is represented as, let us say, D, which is in meter below high flood level for regime condition in a stable channel, is given by this expression, which is D is equal to 0.473 Q by F to the power 1 by 3, where this Q is design discharge in Q max, that is meter cube per second. Then F is the Lacey's silt factor, which is given by 1.76 m to the power half. M is the mean size of particle in millimeter. Now, how to decide upon these silt factor? IS code has given some of the guidelines for the choice of these silt factor, that is IS 3955/1967. We will just have a look at what exactly are these Lacey's silt factor for different type of soil. You can see here that the first column is dealing with the type of bed soil, the second one is with for size of particles which are there in millimeter, and third column gives us the value of this Lacey's silt factor, that is F. Now, here in this slide 4 types of soils are there. In the subsequent one we have some more types. So, like in case here say if the type of the bed soil is coarse silt, then the size of the particle is of the order of 0.04 millimeter, and if this condition is prevailing at the site, you can pick the value of F as 0.35. Like for example, in case if you are encountering the coarse sand as a type of bed soil, and say the size of particle is of the order of say 1 millimeter, then you can use this particular table and pick the appropriate value of this lacy silt factor as 1.76 in case if you have encountered coarse sand as a type of bed soil and the size of the particle is of the order of 1 millimeter. Now in continuation of this particular table, here there are the two other type of bed soil material, that is gravel and boulder. As we all know that the size of particles will keep on or will be quite high in case of the gravel and boulders. So let us say if the type of bed soil is say bouldery and the size of particles usually they are of the order of say 75 millimeter, you can pick an appropriate value of 15.20 as F, which is the lacy silt factor. So using this particular table, depending upon the type of bed soil and the size of particle, you can pick the appropriate value of lacy silt factor F. Now due allowance should be made in scour depth if the waterway is contracted from the regime. Now further, IRC specifications in 1966 and IS code, they recommend that the maximum depth of scour be increased depending upon the section. Now codes, they have given the provision or they have given us the idea that depending upon what is the type of section, to what extent one should increase the scour depth. Let us see here that this table has been taken from those codes and it gives us the idea about the maximum depth of scour. So you can see here that based upon the section, that is in the if it is a straight reach or if it is at a moderate bend, or if you are providing the well foundation at a severe bend, or if it is at a right angle bend or at the nose of pier, there corresponding to the condition where you are providing the well foundation, D is the depth of scour which you have obtained from the Lacey's formula. Now that has to be increased to take care of any deviation from the regime. Is that maximum depth of scour can be like 1.27 D in case if it is the well foundation is being provided in the straight reach, or let us say if it is at upstream noses of guide banks, then it has to be increased by a factor of 2.75, and likewise here say if it is at a right angle bend or if you have the very sharp bends, of course there the scour will be more, and so you have to provide some more maximum depth of square as 2D here we can see. Now this grip length of the well, it can be taken as 1/3 of the maximum scour depth. So therefore, as per IS code, the depth of foundation should not be less than 1.33 times the deepest scour below high flood level, that is HFL. So first thing is that we need to obtain the depth of scour from Lacey's formula. Then we need to increase it depending upon the section where you are providing the well foundation, and the grip length is being then increased by 33%. So whatever is the maximum depth of a square, you have to multiply that by a factor of 1.33 to know the grip length. Now this may however be reduced if an inerodable stratum such as rock is available at shallow depths. In case if you have the rocky strata available at the shallow depth, this increase of the 33% can be reduced using your engineering judgment depending upon the condition at the site. Now this IRC specifications recommend the minimum depth of a foundation as 1.33 times the anticipated maximum depth of scour below HFL. Further, the specification state that depth below scour line should be in no case less than 2 meters for piers and abutment with arches. Okay, so we need to consider these two criteria, and based upon this, whichever is the larger grip length that we get, we need to provide that grip length. Now the depth below the scour line should in no case be less than 1.2 meter for piers and abutments supporting other type of superstructure. If they are with respect to the piers and abutment with arches, the minimum depth below the scour line is 2 meter. However, for other supporting structures or other superstructures, it is 1.2 meter. So this is the how you have to decide upon the depth of the well foundation based upon the scour depth. Now you have to take into account the base pressure and decide upon the depth of the well foundation. That is, at the base of the well foundation, whatever pressure which is coming, it should be less than the allowable bearing pressure. So it's not only the scour depth, but the allowable soil pressure also is one of the deciding factor of the depth of the well foundation. So today we have discussed about some of the fundamental or basic aspects related to the well foundation. The first we discussed that what all are the various type of well foundation. Then we discussed the shape of the well foundation, different type of shapes, their advantages and disadvantages, and then we saw that what all are the various components of the well foundation and their function, and then we had an idea that how one can decide upon the depth of the well foundation based upon the scour depth and the allowable soil pressure. Now how this allowable soil pressure is being calculated, that we will be discussing in the next lecture. Thank you.